Okay, welcome back for the unit on scale, or the topic on scale. What's your goal today? I want you to be able to actually determine the actual measurements of an object based on using the scale, or vice versa. I want you to be able to take objects that are larger than your piece of paper and make sure they fit. So the topic that both of those topics stem from what we call magnifications and reductions. So probably reduction is what most people are most familiar with, because a lot of you have taken tech classes before. And with reductions, basically you're taking a large object or something big, and we're moving it to, something big, and we're move it to fit on a page. So for example, a house, for example. You can't obviously have a set of drawings that are the same size as the house. We have to reduce it down so that it fits. A reduction is easy to pick out because it's always, the one is always first, and then the scale is always the second term. So this always indicates that we have a reduction. So reduction. And when we set up reductions, it is always in the order of drawing to actual. Alright, so for people that took the tech classes, they'll know that 1 to 100 is not uncommon, 1 to 50 when we're working with the metric system. And basically that translates to, it can be 1 centimeter represents 100 centimeters, or it could represent 1 inch will represent 50 inches, which is not obviously not very common, because 1 to 50 is more of a metric. So we're taking something large and we're shrinking it down so that it fits on a page. So that's what we call with our reduction. And when we get into the example in the next slide, I'll show you how that works. But basically, how that will work, how it works, we're going to set up a proportion. So that's why we spent time last unit on ratio and proportion. So basically you'll have your scale. And as I said before, it's going to be drawing to actual. So there's the ratio. When I set it equal to another ratio, we now have a proportion, and this is going to be what we have, or what we're working with. So, and then it'll be in the same order. It's going to be drawing to actual. All right, and that kind of stems. That's actually for both reductions and for magnifications. So I'm going to group that together. I'll put it in the middle because, like I said, it really applies to both here. Reductions, if you've taken a science class before and you've seen a picture of a amoeba or a bacteria or whatever they teach you with the biology, obviously some of that stuff is far too small to see with the naked eye. So what they have to do is they have to bring it up in size. They have to magnify it so that you can actually see the components that make up that particular object. So basically we're taking something small and doing the opposite, something small, and we're enlarging. So we're making it larger so we can see the components a little bit easier. Enlarging. There we are. So it's easier to see the scale with a magnification because the 1 comes second now. All right, the 1 now appears to be second, so this is a magnification. So there is your difference between, when you're looking at scale, how can you tell the difference between a reduction and a magnification? Well, when you compare the two, if it starts with a 1, think about what you'd see in your tech courses. If the 1 comes first, we have a reduction. If the 1 comes second, it's more your science class. So a lot of things in the biology unit will be 1,000 to 1. So it could be 1,000. 1,000 millimeters is 1 millimeter in real life. So I'll put that 1,000 millimeters represents 1 millimeter. All right, or you could have a scale that looks like this. The units don't have to be the same, 50 to 1. So 50 millimeters is equal to, 1 micrometer, which is not very common. We don't have to really worry about it, but I'm just throwing out some examples for you. So that's what we're really working with, and this is what the key to what we're doing today. We're going to be looking at the proportions, how to use our proportion skills from the previous unit in order to determine magnifications and reductions. So if you've done this before in the tech classes, this will seem fairly straightforward. So it wants us to determine the scale for the following objects, and it says that the actual height of this windmill is 20 meters. So I'm going to set up the scale. Obviously the windmill is going to be bigger than the smartboard, so we're looking at doing a reduction. So it's going to be 1 to something is equal to, so remember it's always in the order. I'll do this for the first one. Drawing to actual. So on the other side we'll have the same thing. Drawing to actual. So we set up the ratio on the other side. So the actual height is 20 meters. And what is the height on the page? We need to pull out a ruler. So I'll grab my small ruler. I'm going to work in metric here because I'm working with meters and centimeters. So we go ahead and we measure up the windmill. So the windmill looks like, to me, pretty close to 3 centimeters there. So 3 centimeters. So that means the drawing would be 3 centimeters. And I'll put the units in. It's not necessary at this point. So what we need to find then is we need to find the value that goes in the red circle. How do we do that? We have an anchor chart for that. It's in your notes. Take the number that's by itself. So this time it's on the left side. Take the 1, divide it by its corresponding value. So it'd be 1/3. Get it as a decimal, so 0.3 repeated. You then take that decimal, the 0.3 repeated, and you multiply by the number that's on the other side that wasn't used, so it's the 20. So 0.33 times 20, or 1/3 times 20, and with the calculator I get 6 2/3, or 6.67. And that's your answer. Now 6.67 is not a very common scale. If you're doing construction, you never see something ridiculous like that because it's just a headache. But for our examples here, you're going to find the scales are a little wonky anyway. All right, so on to the second example with the ant. Hopefully you're not thinking the ant is actually that size in real life. If not, you need to start using better stuff. So basically what happens with the drawing or the scale here, because it's a magnification, it's going to be something to 1 because the ant isn't that big. We've made it bigger. We're looking through the magnifying glass. 0 on the other side then, and now I'm going to simplify it down to drawing versus actual. On this other side we'll have drawing versus actual. So what do we know? Well, I know the actual length in real life is 2 centimeters. And from the drawing, I can use the ruler again. So you grab your ruler. Oops, I guess I didn't have to change the orientation. There we go. So to me it looks like 2.4 centimeters. So from there all the way down to here, it's 2.4 centimeters. And again, we're looking for scale here. So we're looking to fill in that missing value at the start. So again, going back to your previous unit, the anchor chart on the wall, you take the number that's by itself, so the 1, you divide it by its corresponding. So we're looking at 1 divided by the other actual, so 1 divided by 2, and you end up with 0.5. You take that ratio that you just calculated, and you multiply it by the other number, the number that you haven't used, 2.4, and you get 1.2, and there's your scale. So 1.2 to 1. So it's not really much of a magnification. The ant actually, according to this, 2 centimeter ant is actually only 20% smaller than that. So 2 more quick examples with that, and then we'll finish it up in the next one. So here the elephant, hopefully again, you've watched enough TV to realize elephants aren't actually that small, and they're not smaller. So that means in real life the elephant must be much larger. So again, it'll be reducing it, so it starts with a 1 to our actual, and then now we want to figure out these particular values. So we have drawing to actual, so it lines up. What information is given? Well, it tells me that in real life this elephant is 450 centimeters. What is it on my drawing? So you take the ruler, I'm just going to match this up, and I'm just going to pick any part here so it looks like front to rear, say 3.1 centimeters. Get rid of my ruler for a sec. So 3.1 centimeters. So there we go. So we take that information, all this information comes from either the drawing or given, and we use it to find our scale. So take the number that's by itself, 1, we're going to divide it by 3.1, which is not a third, so we'll use a decimal in this case, so 0.323. That ratio that we just calculated, 0.323, we multiply it by the number that hasn't been touched or used, so the 450. When I multiply that by 450, I get 145. So the scale here is 1 to 145. So that means for every 1 centimeter, it represents 145 centimeters of elephant. All right. So one last one, just to kind of drive it home. Again, spiders aren't really that big in life, for those that didn't realize that. So, setting up the proportion, it's going to look like that. Again, it's always drawing to actual, no matter what you're doing, science, construction, manufacturing. I know it's a magnification, so the actual, or the 1 will go in the second column for a magnification. So the drawing, I know the actual length is 15 millimeters. Bringing my ruler back down, and the nice thing is it doesn't really matter which way you measure this spider in terms of length or width. It doesn't matter which orientation you use. So from there to there, looks like 2.8 centimeters. So get rid of the ruler. I now know that it's 2.8. So again, you use your corresponding values here, so that I know the actual and an actual. So use the one that's by itself, divided by 15. Make that calculation, 1 divided by 15, so 0.067. Take that value, multiply by the number you did not use, so 2.8, and I get roughly 0.2. So the scale is 0.2, so that's 0.2 centimeters is equal to 1 millimeter when you match up the units here. So it allows you then to make measurements on the animal and find actual or accurate measurements from that. So we scale things down to fit on pages, we scale things up so they're easier to see or work with. So keep that in mind. I'm going to finish up the next part in the second video, and then you can try some of these on your own.